Hey guys, welcome back. All right, we're gonna move on to concept number 3, which tends to be relatively easier compared to the first 5 questions. I understand I kind of throw you guys in directly into graphing vapor pressure graphs. Concept 3, which is describing characteristics of gases pertaining to kinetic molecular theory, is a little bit more understandable, and you can interpret it in a visual fashion much more easier. So let's jump right in. So I'm going to get my handy dandy pen here. Let me move this. Oh, this dialog box is annoying. All right. Sweet. All right. Handy dandy pen. What happens to, number 6, what happens to the pressure when the volume is held constant and the temperature increase? So if you have a box, you have 2 boxes that are exactly the same volume. So let's just say they're 2-liter bottles of Coke, right? Bam. And they're empty, but they have oxygen inside, right? Oxygen inside. Let's just say this one right here, you maintain at a constant temperature. This one here, you add a ton of heat, right? So what happens to those molecules? Those molecules move way faster. They start bouncing off the container like crazy, and the pressure increases because now you have more things bouncing on those containers, right? Question number 7, what happens to the average kinetic energy of particles in a sample of matter as the temperature of the sample is decreased? So going back to this question right here, and this model that I drew, if you decrease the temperature, the pressure also decreases as well because those molecules are moving much slower and you have less pressure on the walls of the container. So, bam. Number 8, gas is compressible because the atoms behave like small hard spheres. I don't know about that one. The collisions are perfectly elastic. The molecules are widely spaced. The temperature is well above the boiling point. So what I want you guys to understand is I'm going to give you the answer, which is C, but I also want you to think about that container, right? A container full of gas molecules, these little dots here. What I want you guys to understand is, see all this space here? There is space inside of gas molecules. So the reason why you can compress a syringe down is because there is so much space between those gas particles that you can easily squeeze them in. Perfect. All right. Number 9, all of the following is true about gases except, okay, keep except, or to simplify it, not in your mind. Okay, individual gas molecules are either attracted or repelled by one another. Individual gas molecules are so small their volume is insignificant. The average kinetic energy of gas is directly related to the temperature. Gases experience inelastic collisions, so average kinetic energy is not lost. Ooh, interesting. So the average kinetic energy is temperature, so that can't be it. Individual gas molecules are so small that their volume is insignificant. This is true. Individual gas molecules are either attracted or repelled by one another. If you guys reference the notes that I gave you back a week ago, they are not. So the correct answer is this one. Gases experience... I'm sorry. This is totally true. This one is not true, so therefore this one would be the answer. They're not really attracted to one another or they repel. They just bounce around. Perfect. So now number 10. Dicarbon tetrahydride has a mass of 28 grams and oxygen has a mass of 32 grams. Which gas will move faster at room temperature? Now, sweet. I love this question. If I have a car, don't make fun of my car, but bam, bam. And then I have another one. Bam, bam. Oh, sweet cars. I should design vehicles for Ford. Oh, goodness. Later time in life. Okay, so if I have a car, they both have the same engine, they both have the same wheels, except one weighs 28 grams, one weighs 32 grams. Now, same scenario. Which one will move faster? So if you weigh less, if you have a less mass, you're going to move faster if all the other elements are kept the same because you have less weight to push around, right? So the correct answer